Welcome to the deep dive. Our mission is simple. Take a stack of information, cut through the noise, and uncover the most important nuggets of knowledge and insight just for you.
We're your shortcut to being well-informed, helping you navigate complex topics without getting lost in all the details.
Exactly. And today we're diving into something really crucial for any large organization thinking about the cloud.
Which is?
Mapping your existing IT estate, everything you have today, to services in Google Cloud.
Yes. That's a big one. And this deep dive, it's based on some excellent material from Darren Lester, the enterprise cloud architect.
DASBO.
That's the one. He's put together a really comprehensive series on enterprise cloud adoption, covers the whole journey, strategy to operations.
Right. And, we're kind of building on previous discussions here, so we're assuming you're familiar with things like cloud strategy, the business case side of things.
Yeah, this mapping piece is really that essential next step, because the big question, the one that keeps, enterprises up at night is, how do you actually do it? How do you get from this complex, maybe slightly messy on-premises world to really getting the value out of the cloud?
Precisely. This mapping process, it's the practical link, it's the bridge, isn't it, between your as-is state and that desired to be state in Google Cloud.
So, okay, before we jump into the how, maybe let's just quickly touch on the why again. Why is mapping so critical?
Good point. Remember those common challenges DASBO talks about? Questions like, how do I even evaluate my existing estate? That's a big one.
Or, how do I migrate these applications?
Mm-hmm.
And maybe more importantly, should I even migrate them?
Exactly. This mapping process, this detailed look, it gives you the foundation to actually answer those questions properly.
And it's all guided by those core cloud adoption principles we've mentioned before. They really act as your compass,
pointing you towards the right target state in Google Cloud. Things like, defaulting to public cloud, using managed services wherever you can.
Definitely leaning into cloud native services. And a huge one, trying to avoid commercially licensed software. That keeps coming up.
It does. Plus, automation, treating infrastructure like cattle, not pets. Yep. The usual suspects.
Documenting everything, managing lock-in smartly, and FinOps. Systemic FinOps from the start. These aren't just buzzwords. They genuinely shape the recommended targets and drive a lot of the value.
Okay, so let's get practical. Step one in mapping is discovery.
Discovery, yeah. You got to figure out in detail what you actually have running today.
Sounds potentially huge for a big company. Where do you start?
It can be, yeah.
Yeah.
But you start by pulling data together, your CMDB, your configuration management database, hopefully. That's got a good chunk of it.
Hopefully.
Then you add data from discovery tools, things scanning your network, and maybe cloud-specific tools too, like Google Cloud Migration Center, which can help analyze what you have.
Right. The goal is to get what DASBO calls an organized view.
Exactly. An organized view of your whole technology landscape.
Okay, so you've got this mountain of data. How do you make sense of it without just staring at spreadsheets?
Well, that's where this visual tool DASBO talks about is super helpful. It's called the hosting on a page, or HoaP.
HoaP. Okay. What is it? Like a big diagram?
Pretty much. Imagine a single diagram that maps out your traditional on-prem setup, but broken down into broad capability tiers.
Like layers of the stack.
Exactly. Everything from the physical stuff up, hosting venue, WAN, network services, perimeter, storage, backup, compute, virtualization, OS, containers, middleware, databases, even CI/CD.
Wow, okay. That covers pretty much everything. So this HoaP gives you that instant snapshot.
Yes, that crucial at-a-glance view. Shows your infrastructure layers, the main vendors, the products you're using.
And helps you spot redundancies, maybe, like having 3 tools doing the same thing.
Absolutely. It's brilliant for that. It becomes a really key artifact for the mapping itself and for gap analysis, especially, if getting out of your data center is a big goal.
Makes sense. Okay, discovered, visualized with the HoaP. Now you start deciding what happens to each bit.
Precisely. For every capability, every product you've identified on that HoaP, you decide its future in the cloud journey. DASBO uses these clear categories.
Like replace. Out with the old, in with a new cloud service.
Yep, that's the ideal. Often. Or you might maintain it, keep using the existing thing, maybe in a hybrid way for a bit, though that's usually tactical.
Okay.
Then there's tactical retain, sunset, keep it short-term, medium-term maybe, but you're getting rid of it eventually. Usually only for existing on-prem stuff, not for new cloud deployments.
And the simplest, eliminate. Just don't need it anymore.
Exactly. Gone. And the goal, really, guided by those principles, is often replace or eliminate, moving towards those managed cloud services.
Well, okay, let's walk through some examples then. Let's use those HoaP tiers. How did these old on-prem things map to Google Cloud? What's the thinking?
Sounds good. Let's start right at the bottom.
Yeah.
The hosting venue, your actual data centers.
Okay, seems obvious. The target is Google Cloud's data centers, surely.
It is, and the rationale was clear, right? You leverage Google's massive scale, their efficiency, that global footprint, 39 regions, 118 zones.
And the sustainability angle is massive, too. Carbon neutral since '07, 100% renewable energy. Moving out of your own data centers is often a big green tick.
Absolutely. It's directly tied to that data center exit strategy.
Big driver. Okay, next up, the WAN, your wide area network.
Right. As workloads shift to cloud and you use more SaaS, your reliance on that traditional WAN connecting your own DCs, well, it should decrease over time.
So the long-term plan is to shrink it, maybe even get rid of it.
Ideally, yes. Minimize that dependency. Now, if you do need hybrid connectivity during the migration or ongoing, Google Cloud Interconnect gives you those dedicated high-bandwidth private links.
But the push is away from those old fixed circuits between your sites.
Generally, yes. Towards a more cloud-centric network model.
Okay. What about inside the network and network services? All those physical routers and switches everywhere?
Yeah, those get replaced by Google Cloud VPCs, your virtual private clouds. And this is a fundamental shift. They're global, software-defined. You can spin them up in seconds. You're leveraging Google's own super-fast network. No more racking and stacking routers.
That's a huge change. Managing software, not hardware. What about things like load balancers, reverse proxies?
Yeah.
You know, those big F5 boxes or net scalers?
Great example. Those traditional, often physical appliances, they get replaced by Google's managed, software-defined load balancers.
And these are built for the cloud.
Totally. They scale automatically, they're highly available, and they plug right into other Google services like Cloud CDN for caching, Cloud Armor for Wave and DDoS protection, Identity-Aware Proxy IAP for secure access control. You completely lose the headache of managing those complex physical or virtual boxes yourself.
That sounds like a massive operational win right there. What about traffic going out? Egress proxies, Zscaler or Blue Coat, that sort of thing?
Yeah, for basic outbound connections and logging from cloud resources, CloudNet is the service. But if you need more advanced stuff, URL filtering, content inspection, applying policies based on identity, then Secure Web Proxy, or SWP, is the Google Cloud tool.
So you can control outbound traffic securely without hairpinning it back through your old on-prem setup.
Exactly. Keeps things cleaner and more efficient.
All right, let's shift to security. Perimeter and access. I know Dasbo has strong views here.
He really does, and it's vital. The mantra is, perimeter-based security is bad, ZTNA is good. That old castle and moat model, trusting everything inside the firewall, it's just outdated. It doesn't work in today's world.
Right. Zero Trust Network Access ZTNA. It's about assuming nothing is trusted, verifying everything all the time, wherever it is.
Precisely. Deny by default. You authenticate and authorize based on identity, device health, context, before granting access to a specific resource, not the whole network.
So this means replacing things like traditional VPNs and those big perimeter firewalls from Cisco, Palo Alto, Checkpoint.
Largely, yes. Replacing them with ZTNA solutions. In Google Cloud, the key services are Identity-Aware Proxy, IAP, and BeyondCorp Enterprise.
How do they work differently?
Instead of giving someone broad network access like a VPN does, IAP and BeyondCorp grant access directly to specific applications or resources after verifying identity and context. It shrinks the attack surface massively. Being on the network doesn't mean you can access everything anymore.
So the trust boundary moves much closer to the actual application. Google Cloud Firewall still exists, though.
Oh, yes. It's still important for fine-grained L3, L2, filtering within your VPCs, segmenting things internally, but it's not your primary defense against the internet in the ZTNA model.
That's a fundamental shift in security architecture. Okay, let's switch to storage, backup, and archive. Heard there are big TCO savings here, too.
Huge potential, absolutely. Let's break it down. On-prem block storage, your ASNAM. In the cloud, you mainly need that for persistent disks attached to VMs, or maybe stateful containers on GKE.
And Google provides that with
Google Compute Engine persistent disks. You get different performance options, redundancy choices, and you stop managing physical SAN arrays. Big operational win.
Okay. What about file storage? The NAS shares.
Well, the need for traditional server file shares often reduces a lot, and user stuff might go to Google Drive. For server needs, like static web content, the primary target is Google Cloud Storage GCS.
GCS, that's object storage, though, not a file system like NAS, right?
That's right. It's fundamentally different, massively scalable, highly available object storage. optimized for unstructured data. Now, you can mount it like a file system using GCS if you see for certain legacy needs. But the strategic direction is usually to adapt applications to use object storage patterns.
And if you absolutely need traditional NFS,
then Cloud File Store is available. But that's usually for specific use cases you can't easily refactor.
Got it. So GCS for objects, persistent disks for block. What about backup and archive? Every company has sprawling backup systems.
And this is where GCS really shines for cost savings. Those traditional backup appliances, tape libraries, complex software, largely replaced by Google Cloud Storage.
How does GCS replace them effectively?
Because it has different storage classes, standard for frequently accessed data, then cold line, and archive for data you rarely touch. The price drops dramatically for the colder tiers.
Which is perfect for backups and archives you hopefully don't need often.
Exactly. Archive storage can be less than a tenth of the cost of standard storage. Plus, GCS has features like object versioning, lifecycle policies to automatically move data to cheaper tiers. It simplifies things immensely compared to legacy backup solutions. The savings can be enormous.
Makes total sense. Pay less for data you don't access. Okay, moving up to the core. Physical compute and compute virtualization, this feels like a major modernization point.
It really is. So your standard by 86 servers, maybe running VMware on-prem, lift and shift to Google Compute Engine VMs, that's an option. Sometimes necessary for commercial off-the-shelf software COTS apps that are hard to change.
But based on those principles, it's not the ideal, is it?
No, definitely not. The preferred target is to eliminate VMs wherever possible. And if you do need VMs, DASBO strongly recommends using GCE directly, not replicating your VMware stack using something like Google Cloud VMware Engine or GCD.
Why is that? Avoid the third-party hypervisor dependency in the cloud.
Precisely. Keep it simpler, leverage the native cloud platform, and even if you use GCE VMs, you can make them more cloud-like using managed instance groups, MIGs, with load balancing for auto-scaling. That gives even legacy apps some cloud benefits.
Okay, so GCE if you must, but ideally, no VMs. What about the really tough stuff? IBM Power, mainframes, IBM Z, those big iron systems.
Yeah, they're the challenging ones, no doubt. But migrations are happening. For mainframes, you've got options. Rehosting is one lift and shift the COBOL code to run on, say, Micro Focus on Google Cloud. Or move ZVM Linux workloads to GCE. Google even has this dual run service to help migrate safely by running old and new side by side for a while.
So rehosting gets you off the expensive hardware, but you still have the old code.
Exactly. It solves the hardware cost and refresh cycle issue. Other options are refactoring or replatforming, maybe converting COBOL to Java using tools like Google G4 or containerizing ZVM Linux apps.
Or just replacing the whole thing.
That's often the ultimate goal. Replace it with a modern cloud-native solution or even a SaaS product. Getting off those expensive niche platforms with their long hardware cycles is a massive driver. Look at Santander. They successfully exited their mainframe. It can be done.
Complex, but the payoff must be huge. Okay, moving up again. Operating systems and containers. Licensing costs fight hard here on-prem.
Oh, they absolutely follow you to the cloud if you're not careful. Lifting and shifting VMs, your OS choice is critical for cost. Enterprises pay a fortune for Windows Server, RHEL, SLES, AIX, Oracle Linux.
And Google Cloud offers free Linux options alongside those.
Yep, Debian, Ubuntu, Alma Linux, Rocky Linux, all available and free. DASBO's example is stark, 5,000 VMs. Choosing commercial Linux over free could cost an extra $13 million over 5 years.
$13 million just for the OS license on VMs.
Wow. It really hammers home that avoid commercial software principle. And using BYO, bring your own license, can sometimes limit your cloud elasticity too, if you're tied to fixed license counts.
So avoid commercial OS on VMs. What's the better alternative to VMs altogether?
Containerization. If the app can be containerized, that's almost always the way to go. Containers are just so much more lightweight, portable, faster to scale.
Because they share the host OS kernel, right? No full OS boot needed.
Exactly. Fewer resources consumed, faster startup, generally cheaper to run per instance, and they're platform independent, reduces that lock-in risk.
Okay, app is containerized. Where does it run on Google Cloud?
2 main places. Google Kubernetes Engine GKE or Cloud Run.
GKE and Cloud Run. What's the difference? Quickly.
Cloud Run is fully managed, serverless, ideal for stateless containers. Think simple microservices, APIs, things that can scale down to zero when idle. Super simple.
Okay. And GKE?
GKE is managed Kubernetes. More powerful. For complex apps, orchestrating many containers, stateful workloads, or when you need specific machine types or configurations. Google manages the control plane. You manage the cluster config.
Right, Cloud Run for simple stateless, GKE for complex stateful. What if you're already using containers on-prem, maybe on OpenShift?
Migrating the containers themselves should be fairly easy. That's the beauty of containers. But, and this is a strong recommendation from Dasbo, move off platforms like OpenShift to GKE when you migrate to Google Cloud.
Why? Why not just run OpenShift on GCE VMs? Seems easier, maybe.
That's the trap. Replicating the on-prem model. You run OpenShift on GCE, you manage the underlying VMs, you manage the OpenShift software, and you pay Red Hat for OpenShift licenses on top of the Google infrastructure costs.
Ah, okay. And with GKE?
With GKE, Google manages the Kubernetes control plane. There's no separate GKE license fee. You pay for the managed service and underlying resources. It's the market leader. And GKE Autopilot mode gives you a hands-off experience where you basically just pay for the running pods.
So much less management overhead and lower cost.
Significantly lower. Dasbo's comparison shows GKE around $2.7 million versus OpenShift at $6.5 million over 5 years for a similar setup.
Wow, more than double the cost. That's compelling. What about application servers? WebSphere, WebLogic, JBoss?
Many of those enterprise Java apps plus .NET, Node.js, they can often be containerized using free open source runtimes.
Like Tomcat instead of WebSphere. Or .NET Core on Linux.
Exactly. Or Wildfly, Open Liberty. By doing that, you ditch the huge commercial licenses. The IBM WAS example Dasbo uses suggests a potential $3.2 million TCO saving over 5 years for just 400 servers by moving off WAS and containerizing.
Another multi-million-dollar saving just from switching software and using containers. This pattern is clear.
It really is. Back to those core principles again and again.
Okay, last big one. Databases. Feels like another huge licensing cost center with things like Oracle.
You are absolutely right. Databases. This is arguably where the biggest potential TCO reduction lies. Moving away from Oracle, SQL Server, DB2, towards managed open source options.
But migrations, say from Oracle, aren't they tricky? Proprietary SQL and all that?
They can be, yes. There's often custom PL SQL or other extensions beyond standard SQL.
Yeah.
But tools and expertise exist to help migrate or refactor that code. It's definitely solvable.
So what are the go-to Google Cloud database services then?
For transactional stuff, OLTP, Cloud SQL, is the managed service for PostgreSQL, MySQL, even SQL Server if you need it. For higher performance, Alloy DD for PostgreSQL is a great option, fully PostgreSQL compatible, but faster.
Okay.
If you need massive scale, global consistency, super high availability, like 99.999% SLA, then Cloud Spanner is Google's unique distributed SQL database. And for analytics, OLAP, data warehousing, it's BigQuery. Petabyte scale, serverless.
A range of options, but mostly managed and open source focused.
That's the key. And the cost difference, again, it's huge. Dasbo's comparison. 100 Oracle Enterprise DBs on OCI versus equivalent Cloud SQL PostgreSQL instances. 5-year cost. $15 million for Oracle, $6.3 million for Cloud SQL Postgre.
Whoa. An $8.7 million saving on just 100 databases. That's incredible.
It really highlights the cost impact of those licenses. And the crucial theme, like everywhere else, is managed services. Don't just install PostgreSQL on a GCE VM and manage it yourself. That misses the point.
Right, you replicate the on-prem burden.
Exactly. Use Cloud SQL, use AlloyDB, use Spanner. Let Google handle the patching, backups, HA, scaling. Free up your DBAs to work on data modeling, performance tuning, adding real value.
Okay, this has been incredibly insightful. We've walked through Dasbo's framework for mapping that entire IT estate, tier by tier, to Google Cloud services, and those principles really shine through.
Avoid commercial software, embrace open source, containerize away from VMs, use managed services. It's a consistent message.
And it's not just about modernization, it's about serious TCO reduction, as those examples showed. That HomeUp visual seems like a fantastic starting point for anyone undertaking this.
Definitely. Seeing your current state mapped out really helps visualize the transformation needed.
Now, we've covered the what's mapping technologies. But, that's only part of it, isn't it? We haven't really dug into the reusable patterns for using these services well, or the anti-patterns to avoid, like that OpenShift example.
Or the processes, the tools, the teams you need to actually make this happen and operate it effectively at scale. The technology mapping is one thing, executing is another.
That actually leads to a really important question for you listening. Given this clear technology path and the benefits, what organizational capabilities or changes do you think are most critical to actually pull this off successfully?
Yeah, it's moving beyond the tech map to the people and process changes. That's often the harder part.
Absolutely. Something to think about. And speaking of building those capabilities, in the next part of this series, we're going to dive into site reliability engineering SRD adoption best practices.
Very relevant.
Yeah.
Key for operating effectively in the cloud.
Definitely. So that wraps up our deep dive today on mapping your existing IT estate to Google Cloud. Hopefully, seeing those specific mappings and, importantly, the why behind them, especially the cost savings from managed and open source services, gives you a clearer path forward.
And do check out Dasbo's full series for even more detail. It's incredibly valuable stuff.
Thanks for joining us for this deep dive.